We want to continue to look at our one-sided limits here by doing a little bit of evaluation and simplification. So evaluating the limit as x approaches 2 from the left. The issue here is if we plug in 2 and do direct substitution, I'm going to have 0 over 0, which is do more work. So we're going to start by doing some more work. So the limit as x approaches 2 from the left, at the top, that could be rewritten as negative x plus 2. The denominator, we've got x plus 2, x minus 2. And then if I simplify a little more, the limit as x approaches 2 from the left. At the top, I can factor out that negative 1, which is going to give me an x minus 2 at the top. So I've got x plus 2 and then x minus 2. I can see my x minus 2's are going to cancel. And I'm left with the limit as x approaches 2 from the left of negative 1 over x plus 2. Now, at this point, we can plug in a number that is very, very close to 2 on the left. So something that's really close to 2 on the left is 1.999999999999999. Lots of 9, something that's really close to it. And if I were to plug in that 1.9999999999999 plus 2, I would have 3.99999999999. So negative 1 over that 3.999999999 is going to be really close to 4. And in essence, what we have happening here is the limit as x approaches 2 from the left is the same result as if we were to plug in a 2 to begin with. So we've got a negative 1/4. So as we look at these approaching from the left and right, ultimately we're asking if we're approaching the two-sided limit, what would the answer be? Example 3, this one's approaching 0 from the right, and we've got our special trig function right there. So let's start by simplifying by pulling out that 1/4. So 1/4, the limit as x approaches 0 from the right of the sine of 5x over x. I might say, this sure doesn't look like what we have done before, but we can make it look like something that we have done before. And what we saw was that the sine of x over x, as we took the limit as x approached 0, this was going to equal 1. But I could have also said the limit as x approaches 0 of the sine of 2x over 2x equals 1. Or the limit as x approaches 0 of the sine of 3x over 3x is going to equal 1. That's the idea that we've got right here. So since I've got a sine of 5x, in order for that to simplify down, I need the denominator to also have a 5x. And for me to do that, I need to multiply both the numerator and denominator by 5. So we've got 1/4 times the limit as x approaches 0 from the right of 5 sine of 5x over 5x. And now we'll pull this leading 5 out in front. So 1/4 times 5, the limit as x approaches 0 from the right of the sine of 5x over 5x. Now this piece right here, come back here, there we go. This piece right here is a special trig function, which is going to equal 1, which then means as I evaluate this, my limit as x approaches 0 from the right is going to be 5/4.